Hello again. In this video we're going to look at, with trigonometry, how to know which ratio to use. Which ratio to use. And what do I mean by that is that sine, cos and tan are all our ratios. So I've got SO, CA, TOA. Do we want to use sine, cos or tan? They're the three options, and we've got to use our brain to figure out which one we're supposed to use. And so what we're looking at is which one uses the angle, which one uses the angle and the two mentioned sides. Okay. The two mentioned side, what I mean by that, if you're given the length of a side or you're trying to find the length of a side, then they're the sides that we're interested in. Okay, so I think I'll just go straight to like a quick example before I get into some proper examples. But let's just look at a triangle and say we know that that is 31 degrees, and we know this side over here is 15 centimeters, and we're trying to find this side over here. So which ratio should we use here? And what we've got to look at is what we know and what we want to know. So let's just label the things that we know and we want to know. What side is this over here? That is the hypotenuse. Okay. This one over here is the opposite side, and this one here, and I'll just label it in green, is the adjacent side down here. Why did I label that in green? It's because we don't know it. We don't know this length, and we don't want to know it. There's nothing that we care about with that particular value there. We don't care about adjacent. So what we're looking at, what is the ratio that has an angle, so theta? Which one involves the hypotenuse, so h, and also involves the opposite side, so O? Which one involves those three? So this one here, we've got sine theta is equal to opposite over hypotenuse, and bang, there it is. That's the one we want. Sine theta equals opposite over hypotenuse. So the ratio that we want is sine theta equals opposite over hypotenuse. And so for this particular triangle, what we have is sine theta, the angle is 31, so sine 31 is equal to opposite, so 15 over the hypotenuse, which is x. And so there's our ratio. That's what we're after for this particular triangle. We're using the sine ratio to connect the angle and the two sides, the opposite side and the hypotenuse side. Okay, let's just do another example of that. In fact, let's just do a couple. All right, I'll draw a few on the page. Okay, so we'll have x there and 21 meters, and let's have an angle of 70 degrees there. Okay, and I'll do another one. Go that way. Try to mix it up a little bit. Try and trick you. Now let's go 25 degrees here, and we'll go 4 and x over here. Okay, so we're just trying to find, at this stage we're not solving anything, we're not trying to find the lengths or anything, we're not trying to find x. All I want to do is to be able to find the ratio that connects these three things. So let's have a look at this one here. This one, firstly, label the sides. So here's 90 degrees, here's the longest side here, so that's your hypotenuse. There's your angle that we're talking about, 70 degrees, so opposite that is x, which is your opposite. Okay, 21 meters, that's the one that's left over, that is your adjacent side there. Perfect. Here we go. So let's have a look at this. Now I'll just write our ratios up here. So SOCA TOA, SO, CA, TOA. There we go. SOCA TOA. Let's have a look at how these goes. We want a ratio that doesn't have the hypotenuse in it. We want the ratio that only has the angle, the opposite side, and the adjacent side. So we want something that has the angle, the opposite side, and the adjacent side. So which ratio is it? So sine equals opposite over hypotenuse. No, that's not it, because we don't want the hypotenuse in there. We don't care about the hypotenuse in this question. Cos equals adjacent over hypotenuse. No, that doesn't work either, because we want something that has O and A in it. So let's look at tan. Tan equals O over A, opposite over adjacent. That is the one we want. So for this question, we've got tan theta equals opposite over adjacent. Therefore, tan, what was the angle? 70 degrees equals opposite, which is x, over our adjacent side, which is 21. And that's the ratio that we're talking about for this triangle. And that will help us solve for x in a second. I'll show you how to do that. Okay, so that's that one. Let's have a look at this one over here. Firstly, label the sides. There we go. There's the hypotenuse there. Hypotenuse. We've got angle there, so this side over here will be opposite because it's opposite the angle, and the leftover side is the adjacent side there. Okay, beauty. So what we want is we want a ratio that connects the angle to the hypotenuse to the adjacent side there. Okay, that doesn't involve the opposite side. Which of these doesn't involve the opposite side? Sine has opposite in it. Tan has opposite in it. Cos does not. Cos has adjacent and hypotenuse. Adjacent and hypotenuse. So that's the one we want. So let's write it out. Cos theta equals adjacent over hypotenuse. Therefore, cos, the angle is 25 degrees. So cos 25 is equal to the adjacent side, which is up here. So 4 over the hypotenuse, which is here, x. And that is your ratio for that particular triangle. And that's how we set up the ratios. And in the next video, we'll sort of finish these types of questions off with knowing how to solve for x here for those ones. Enjoy!